Hey, Southfield Lights Math Industry, and we are going to take a look at the chain rule. So, in the past, we have been learning about geometry in terms of finding out proofs, trying to back up your theories and your statements, trying to understand if this is congruent to that, and converse, inverse, contrapositive. But if you ever heard, or if you ever had problems coming up with ideas to give your reasons when you get your statements in your proofs, that's because all that in geometry is all about logical thinking. And today's lesson on the chain rule is going to actually help with logical thinking. But why is it called the chain rule in the first place? Well, with the chain rule, it means a chain of reasoning and statement conditions, and it can be connected with a sequence. Like if you say 90 degrees is equal to a right angle, and two right angles equals its congruency, basically what you're saying is you're backing up your reason to bring more reasons, to bring even more reasons. So what we can say is we are going to see a lot of equations that condition A is going to bring you to condition B. Condition B is going to bring you to condition C. Condition C is going to bring you to condition D. And condition D is going to bring you to condition E. And so on. So that can be an example of a chain with conditions that sort of domino effect and can bring you to another condition. So here can be an example of a condition where we can explain why mathematics is important to us in our daily lives, and we could also say how it could also be a chain. So we could say, if we have no mathematics, this means that there's nothing or it doesn't happen. If there's no math, it means it will bring us to no physics. If there's no physics, it will gonna bring us to no science. If there's no science, it's gonna bring us to no biology. And the thing about biology is it's the study of life and matter. But if there is no biology, that means we would be, yep, you guessed it, dead. Well, this chain can be an example of why we need math and how it can be a chain. Because one condition can lead to another condition, which can lead to another condition. Well, here's what we have. If there's no math, there's no physics. No physics, no science. If there's no science, there's no biology. And if we have no biology and it's a study of life and matter, we would be dead. So that could be an example of a chain rule. Let's look at one more. So this chain rule focuses a lot about Yu-Gi-Oh! And in Yu-Gi-Oh! There's a lot of stuff that happens that will cause even more things to happen. Here's an example. So if I have the monster Lava Golem, then I attack the opponent directly, it's going to cause the opponent to activate the Pelazonic Candia trap card. And what that trap card does is it brings me to have a card attack negated. So the card that I attack with is going to be negated, and it's going to be in defense position. However, After this is being used, Palazona Candia goes to the graveyard, and then the opponent loses 400 HP, and then we win the duel. So it goes from Lava Golem to Palazona Candia to negate card attack to Palazona Candia goes to the graveyard. Then the opponent loses 400 health points, and then we win the game. So here's an action version of the chain rule.
I refuse to lose. My turn. I still believe in my cards. I draw.
Lava Golem's effect activates!
I can still turn this duel around. Time to battle. Here we go. I attack your life points directly.
I don't think so. I activate a face-down card. My trap activates.
Impossible! No! I wouldn't have been victorious had it not been for the help of my cards and my...
That is an awesome duel, but how can we use the chain rule mathematically? If we understand how to use English sentences to understand a chain rule like this and this, well, what happens if we do it with math? Well, here's an example. This assignment, what we're supposed to do is we're supposed to make a chain out of these. Like condition A is going to bring you condition B. Condition D is going to bring you to not condition B. And not condition C is going to bring you to condition D. What can we make as a chain? There's a lot of answers. Type in the comments below what you think an answer is. Well, we can think logically about this. What my geometry teacher wants to do, or taught me to do, is try to look for a starting point that has a variable or a condition that is alone. Like, B is not a good choice because there are mentioned in 2 equations or more. A and not C, however, can work. Let's think logically. So if we say that A is going to bring you to B, that tells you that we use this one and we can't use it once more. Now, we can say we have to start with B, but nothing starts with B. What we can do to think logically is the second one. When you're trying to make a chain, the conditions are always true, even if it's a converse or a contrapositive. So what we're going to do is we're going to turn this into an inverse. So we can say that B is going to bring you to not D. The reason why we did that is because we have D is going to bring you to not B, but writing the inverse, we can say B is going to bring you to not D. So what we did is we switched the thing around. So now we have to start at not D. And here comes our last problem, or our last step. Not C is going to bring you to D. So we can say the inverse operation, or the inverse way of saying that, is not D, is going to bring you to C. We switch it around again. The last step we have to do before we answer this question is to come up with a conclusion. And we can conclude that condition A, when it's triggered its effect, it's going to bring you to condition C. Because it causes a chain reaction to do this, this, and this until it gets to condition C. So we're going to say that our conclusion is A is going to bring us to condition C. Just like what happened in that Yu-Gi-Oh! Duel. When I attack with Lava Golem, it domino effects for the opponent to lose 400 HP and lose the duel. And that is how we can do it mathematically. And that is how we can apply the chain rule to real-world situations and mathematically. I hope this video has helped you understand the chain rule. Thank you for watching Top Fingerlines Math Industry. Like and subscribe!